Hey everyone, welcome to today's Explainer. I am so excited to jump into this one with you because, honestly, we're looking at something that feels like it was ripped straight out of a sci-fi movie, but it is very, very real. We're going to take a deep dive into this fascinating intersection where cutting-edge space engineering meets, well, raw economics. We're looking at how a robotic startup over in Zurich is completely rethinking how we live and work in orbit. So grab a coffee, get settled in, and let's explore this mechanical marvel, the four-armed space robot. Okay, let's dive into this. $140,000. Now, that's not the price tag of a luxury sports car or even some tiny custom piece of satellite hardware. No, that staggering number is the estimated cost of just one single hour of an astronaut's time in space. It's wild, right? Getting humans into orbit, keeping them alive, supporting them up there, it is astronomically expensive. And when literally every minute is worth thousands of dollars, efficiency isn't just a nice-to-have, it's an absolute necessity. But here's where we hit a massive, expensive bottleneck. Over a third, a full 35% of precious crew time on the International Space Station is eaten up by routine maintenance. Just think about that for a second. We're spending millions upon millions of dollars to send the absolute brightest scientists, engineers, and pilots up into microgravity, and they end up spending over a third of their time essentially doing household chores. It's just a massive, glaring inefficiency in the orbital economy. To really wrap your head around the sheer scale of this problem, consider this. Just one single cargo unloading cycle can take up to 50 hours of human time. 50 hours! So when a resupply ship docks, this highly trained crew literally has to stop pushing the boundaries of human knowledge and instead spend days acting like high-tech warehouse workers. The math just doesn't work out long-term, does it? And that sets up an urgent, really desperate need for some kind of automated solution. So let's move into Section 1. The $140,000 problem, or the high cost of space chores.
Just think about the actual logistics of living in orbit. We're talking unloading cargo, sorting supplies, tracking inventory, moving heavy equipment from one module to another, plus all the basic routine maintenance. Now, what do all of those tasks have in common? Well, none of them actually require human judgment. They don't need intuition or creative problem solving. They really just require the physical ability to move through tight corridors, hold steady in zero gravity, and manipulate objects with precision, which means they are the absolute perfect targets for automation. Which brings us to Section 2. Meet the Helios robot, Zurich's alien solution.
Enter Orbit Robotics. They're a startup out of Zurich, which, by the way, is actually one of Europe's absolute strongest robotics engineering hubs alongside Munich and Delft. And their solution? Helios, a four-armed space robot. Now, you might be looking at this and wondering why it looks so entirely alien. Well, here on Earth, we are completely obsessed with walking robots, right? But in microgravity, legs are entirely useless. So the crucial point is that Orbit Robotics completely ditch the legs and replace them with two extra arms. These act as both mobility aids to crawl around the station and as actual working hands. It completely rethinks what the anatomy of a worker should even look like.
All right, Section 3. Built for zero gravity. Engineering for the environment. The brilliant simplicity of this four-armed anatomy really just comes down to Newton's laws of physics. See, a traditional two-armed humanoid robot simply can't stabilize itself and work at the same time in zero gravity. Think about it. If a two-armed robot turns a wrench up there, its whole body is going to spin in the opposite direction. Helios solves this so elegantly. Step 1, it anchors itself to the station interior using two of its arms. Step 2, it handles the cargo, tools, or equipment with the other two. It's incredibly practical.
But that begs the question. How do you build four arms without making the robot way too heavy or bulky for the super tight confines of a space station? The engineering solution here is tendon-driven arms. Instead of cramming heavy motors at every single joint, like the elbows and wrists, the heavy motors actually sit way up near the shoulders. They transfer force down through cables and spools, honestly exactly like the tendons in a human hand. This specific design keeps the arms incredibly lightweight, while still maintaining that full, complex range of motion you absolutely need for station work.
Now, what's really interesting about this slide is a crucial insight from the engineering analysis. It turns out that this mundane-sounding rolling contact elbow joint is actually one of the most critical engineering decisions in the entire system. Helios uses this specific joint for smoother, much more controlled movement. Why does that even matter? Because in microgravity, sudden or uneven motion is an absolute disaster. A jerky elbow movement can completely destabilize the robot and whatever super expensive cargo it happens to be holding.
So this rolling joint, while it might sound kind of simple on paper, is literally essential to making the whole thing work.
And this brilliantly illustrates a massive philosophical divide in modern robotics. Think about Earth-bound humanoids for a second, like Tesla's Optimus or Unitree's G1. They are entirely shaped around gravity. It's all about balancing on legs and navigating flat surfaces. But none of that matters in orbit. Helios starts with the constraints of the actual environment and designs backward. You get 4 arms, built specifically for anchoring in zero gravity.
This really highlights a broader, massive shift we're seeing in the robotics market. We're moving rapidly toward highly specialized form factors, rather than just forcing a one-size-fits-all humanoid to do everything. You've got companies like 1X shipping bipedal humanoids specifically tailored for home use. You've got iRobot's founder building an AI companion robot that literally has bear cub ears. And then you have Helios representing this philosophy of building the body specifically for the environment. It results in a form factor that looks totally, wonderfully alien here on Earth, but is absolutely perfect for orbit.
Moving on to Section 4, the future space economy and scaling orbital habitats.
Let's move to and see how this builds, because this specific engineering unlocks a massive future market. Step 1. SpaceX's Starship program is designed to dramatically increase cargo capacity and drastically lower launch costs to orbit. Step 2. As those launch costs fall exactly as projected, the sheer number of commercial space stations and orbital habitats is going to multiply. And Step 3. Every single one of those new stations is going to need maintenance, logistics, and cargo handling. The demand for autonomous maintenance literally skyrockets with every successful Starship flight.
So while Orbit Robotics hasn't fully disclosed their pricing or their funding just yet, their core value proposition is absolutely rock solid. It is the ultimate pitch to space agencies or commercial operators like Axiom Space. They can basically walk in and say, hey, we give you 4 arms custom built for zero gravity, and we save you $140,000 for every single hour of human time we replace. From both an engineering and an economic standpoint, that is an argument that's incredibly difficult to dismiss.
Which leaves us with a final thought to ponder as we wrap up this explainer. The commercialization of space isn't some distant sci-fi dream, it is happening right now, right above our heads. The habitats are coming, the labs are coming. But as launch costs fall and space really opens up, who's actually going to do the heavy lifting in orbit? Will it be humans holding wrenches, or will it be 4-armed robots anchoring themselves to the walls? I think I know where the economics are pointing. Thank you so much for joining me for this explainer. I hope you found the engineering and the business behind Helios just as fascinating as I do. Keep looking up and keep learning.